Okay, so this is going to be the video for 1.4 and 1.5. I'm going to do 1.4 here first, and then we'll transition into the part that's on 1.5. In 1.4, it's all about solving equations for a given variable or a specific variable. Okay, and so what we have to realize is that some equations are written in a format where no variable is alone. Other times they're written in a format where a variable is alone, but it's not the one we want alone. And so we need to be able to rewrite it and get it into the terms we're looking for. So early on in your assignment, you're going to be dealing with pretty straightforward XY equations. And an example of that would be question number 10. Now number 10 from your text says 15x plus 4y equals 9. And then they say after the fact, little semicolon, x is going to equal negative 3. Now, we need to understand this x equals negative 3 is an afterthought. It's something that we do after we've done the first step. In the instructions to 10, we're told that we need to solve the equation for y. That means we need this guy right here all by himself. So, the question is, how do we start moving things away from it? I'm going to look at this entire left-hand side and look for anything that I can easily move. That's pretty straightforward, easy. So we're always looking for simple math first, like addition and subtraction. I notice that the 4y is being added to this 15x. So if I were to subtract 15x, they would zero out, they make a zero pair, and all that would be left on the left-hand side is 4y. So I like that as an approach. So I'm going to minus 15x from both sides. Those go, like I said, go to 0. I have a 4y. Of course, my equal sign comes down. Now 15x and 9, they don't combine, so I'll just write negative 15x plus 9. I could write 9 minus 15x. It makes no difference which way you do that. Now I come back to this left side. Y is still not quite alone, but I notice the 4 is hanging out there. If I think about the math that keeps them connected, this is 4 times y, so I want to undo that multiplication. I'll do it by dividing. When I divide 4 by 4, I get 1, and 1 times y is just y. But to do that here, I need to do it on the right. And so I'm going to type it in like this, or write it down like that. Negative 15. 15 and 4 do not simplify, and neither does 9 over 4. So I'm going to write my answer just like that and call it good. So as long as there's only one y in the entire equation, I can just peel those layers off. And just like that, take away addition, subtraction, then go for multiplication. It does get a little bit messier later on in the assignment, where we have to move multiple things or where things aren't quite as clean. If we take a look at question number 26, for instance, it gets a little messier because the x's and y's, there's more than one y in the problem. So 4x plus 7y plus 5xy equals 0. And then they tell us that x equals 1. And I forgot to do that piece up here. We were told x equals negative 3, so if I plug negative 3 in, I have negative 15 over 4 times negative 3 plus 9 over 4. Negative 15 times negative 3 becomes a 45 over 4 plus 9 over 4. If I add that, I'm going to get 54 over 4. And those both divide by 2 to make 27 over 2. Or 13 and a half if you plug it in to a calculator. Or you physically divide. Now back down to here 26. The issue is that y shows up twice. And so I can't solve it by just peeling things away from them. In fact, I actually need to find some way to combine the y's into the same thing. The problem is that the 5x and the 7 make it so they're not like terms. For sure, though, this 4x isn't helping, so I'm going to move it right now to the other side of the equal sign by subtraction. Again, that zeroes out. I get 7y plus 5xy equals negative 4x. At this point, I notice that there's a y in both of these terms. So I am going to write y, and then I'm going to start a parentheses. The idea here is that I'm factoring the y out. It's like I'm pulling it out. But I can't pull it out of that without pulling it out of this term as well. So as I pull those y's out, I'm left with a 7 plus 5x. And you could think about distribution and how if you did multiply the y back, you would have gotten the same thing you had started with. But now that I have that, and y only appears once in the problem, I can divide by this parentheses, 7 plus 5x, on both sides. And by doing that, those cancel, and I now have that y will equal negative 4x over 7 plus 5x, or 5x plus 7. Then, that's first answer, if I were to plug in 1 for x, y would equal negative 4 times 1 over 7 plus 5 times 1. Well, negative 4 times 1 is negative 4. 7 plus 5 times 1 is, of course, 5, plus 7 is 12, making this negative 1/3. Okay? All right, so that's really what we're doing in 1.4, and that's our focus. My biggest focus is on these guys right here. Can you rewrite the equation? I assume most, if not all of you, can plug numbers in to equations pretty easily and get your answers. But it's that rewriting the equation that's really crucial. So now we're going to transition over to 1.5. 1.5 is about finding patterns in equations and building equations so that we can solve problems. So as you look at 1.5, a lot of it is stuff that there's not a lot of, I don't know what's the word, there's not a lot of rules per se. It's more just what makes sense. Let me give you some examples. If we look at question number 13, okay, there's an XY table. Whoops. Don't mind my skewness there. Twisted a little. It's 0, 1, 2, 3 for the X. And then it's 46, 36, 46, 36, 26, 16. And what we're supposed to do is build a linear model, which means a linear equation, which should fit this format. Y equals mx plus b. M is the slope, and b is the y-intercept. Okay? Now, just so we're clear, slope means that from one point to the next, how much does it go up? How much does it go over? So, for instance, if I look here, it's going down 10, right? We can see it's subtracting 10. But I have to divide that by whatever this changes. It goes up 1. So I always take this y change and I divide it by the x change. So a negative 10 divided by a positive 1 means my equation should say negative 10x. But now I need to know what is the b, or the y-intercept. Okay, so this is not a good model of this graph because that one's going up and this is a negative slope. The question is, if this slope is negative like this at negative 10, where is it crossing? Right there. That's the question. What's the value? Well, if I think about this line, the y-axis, I know that everywhere on there x will equal 0. Okay? On this line right there. X must be 0 on this line. And if x must be 0, then if I go to where x is 0, I'll know what my b value is. So this is plus 46. Okay? So as long as the x is going up by 1, the change in the y will be the slope. And if you can find what x is, when x is 0, what y is, that will give you the y-intercept. So you're going to see quite a few of those. And then you're also going to see some questions where you deal with posters and trying to think about how do you space things properly. Let's look at one other example. If we look at question number 20. 20 is one of those questions where we analyze someone else's work. The XY table goes 0, 5, 10, 15, etc. And it goes 7, 17, 27, 37. And so doing the same process, y equals mx plus b, I know right away, because x is 0 gives me y is 7, that should give me plus 7. The question really is, what is the slope? What goes next to the x? Normally, if I start looking at this, I notice, hey, these go up by 10, right? And so initially you might think, oh, it's 10. But you have to remember to compare it to what's happening to the x. The x is not going up by 1. It's going up by 5. And like I said in this other question here, I took negative 10 divided by positive 1. I need to take this 10 and divide it by this 5. 10 over 5. That's the change in y divided by the change in x. That's how we define our slope. 10 over 5 is 2. The reason this happens is we're trying to figure out what is it going to happen if I only move one space. If it moves 10 spaces in the y when I move 5, then one little space in the x should just be 2 in the y. Because if I did 5 of those, I would get to 10. All right, so that person who made the mistake, they put 10x instead of 2x because they just assumed that it was always the difference between the y's, which isn't true. Let's look at one of the word problems just as a way to finish up and send you on your way. If we look at the scuba diver question, which is question number 26, okay? Scuba diver is below the water 165 feet down. Okay, so we'll put that on 1. Negative 165 feet down. They're going to go up 30 feet every minute, so per minute. Now we could build an equation for this, but really the question we have is how many minutes before I hit the surface and can take a deep breath of fresh air in case my scuba tank runs out of oxygen? At what point do I get up there? And so as we think about that process, we've got to think, well, how many of these go into there? And so an easy way to look at it is the distance equation that you used earlier in this assignment. It's printed in the book as a guide for questions 3 through 6, but we can use it here as well. The distance we want to cover equals the rate we're moving at times the time it takes us to do that. Well, the distance I'm trying to go up is 165 feet. So I can say that 165 feet is my goal. The rate I'm swimming up at is 30 feet per minute, and I need to times it by however long it takes me to do that. That tells me I can divide both sides by 30, and it just so happens that the time it takes me to get up turns out to be 5.5 minutes, which is a really long time to be holding your breath, so you definitely need to be moving out before you run out of oxygen in those scuba tanks. But I hope this helps. I hope this gets you to where you can kind of finish up those 2 assignments and really kind of hit the ground running. So good luck, and we'll see you in class. Thanks.